I am Daniel Kamler from Mosta, reading for a degree in Electrical and Electronics Engineering in my last year of study, with my thesis focusing on the manipulation of virtual objects with the unaided hand Iron Man style. This will consist from 3D visualization using the Oculus Rift, which are virtual reality glasses. The hand gestures and hand position will then be extracted using image processing. This will then provide an innovative means of human-computer interaction for computer design applications. I entered this project with a good friend of mine from university, Antonella, because we team up on practically every group project at university and therefore have a lot of experience working and brainstorming together. The main reason for entering was purely the big challenge in designing a robot, let alone a combat-worthy one. With regards to price limiting, there was practically none, but I have no regrets. The same high-quality parts can be used if I ever realize my dream of competing in a foreign Robot Wars competition. This is my robot Hades. It opens up using wings. Which is very advantageous when servicing in the pit stop. The first system is the weapon, which consists of the paintball tank, which stores all the air. This, upon sending a signal from the controller, sends the air through the regulator to the piston, which opens up the arm to lift the other robot. The second system, the drive system, starts off from the brushless motor controller, which controls the brushless motor, and this sends its mechanical power to the gearbox, which in turn drives the wheels. All of this is powered from the lithium polymer battery, which is controlled from the driver's hand.
The primary aim for the construction of Hades was always the weapon. The initial dream was to construct a pneumatic flipper which had never been constructed in the history of the local Robot Wars. It was constructed out of a 300-bar capable paintball tank connected to regulators to bring down the pressure to a 10-bar used by the pneumatic piston. The challenge was pretty big in this part of the robot because pneumatic regulators with a high flow rate for a fast-moving piston were very hard to come by. And also, filling up the tank to the competition maximum pressure of 700 psi was problematic too, because it required another regulator, which was eventually rented locally. A circuit was then designed so the piston could be controlled by the driver, with further plans to make the actuation automatic. The fitting of the weapon system was the next challenge, because of the limited dimension imposed by the rules. This was achieved through modeling software together with the structure of the frame seen underneath the wings. The drive system was constructed out of high-speed brushless motors because the aim was for a fast robot, so brushless motors were the obvious choice in this case. The design of their specifications was very detailed and was designed in a spreadsheet, so that the information of a brushless motor could be entered in and the output would be indicative of its usefulness or not. It contains two 1.5 kilowatt motors supplied from a 4 amp-hour lithium polymer battery. The transmission is then achieved through a worm-wheel nylon gearbox, which provides the required gearbox reduction.
The disadvantage with Hades was the transmission because of the low ground clearance and small tires. But on the other hand, a strong point of ours was the chassis. It was built to withstand high energy impacts. In fact, after finishing the welding, I drop tested it from a height of 1 story just to check for deformations. The results were very satisfactory, and it showed considering the fight with Pac-Man. Owing to our impaired mobility and maneuvering, the weapon never hit its mark during battle, and has yet to see the day where it will flip another robot. The mechanical design though is very intricate, because it takes into consideration all the variables such as force, distance and placement. I personally consider the weapon system to be the favorite part of my robot. Upon retelling the story, everything sounds easy, but the difficulty is that each system has to be designed as a whole, not by parts. Every part affects each and every aspect of the system. Building the robot has never been such a satisfying venture. It changed my view of myself from feeling like a student engineer to feeling like an actual engineer.